Next topic is chain rule. The definition of composite function. Suppose f is the function of u and v, and u and v are the function of t. Then f is called composite function of t. So f is function of u and u and v are the functions of t. Then f is called composite function of t. And in this case, if you have to find the partial derivative of this f with respect to t, or the derivative of f with respect to t, then it is by using chain rule. So f is the single variable function of t, and so its derivative is denoted by df by dt. Instead of dA by t, write df by dt, and it is what dA by u. Why the notation dA? Because f is the function of u and v. F is the function of two variables. If function is function of two variable or three variable, that is multivariable, then it is denoted by, its derivative is denoted by notation dA. And if the function is single variable function, then its derivative is denoted by notation d. Okay, small d. Okay, so the f is the composite function of t, and therefore f is the function of single variable function, and so its derivative is denoted by df by dt. And if we have to write the derivative of f with respect to u or v, then use the notation dA. And if I had to write the derivative of u and v with respect to t, then u and v are the single variable function of t. Then its notation is d, small d. So when we use the notation dA, if the function is multivariable, function is a function of two or three more than two variables, okay, then denote the notation, use the notation dA to denote the derivative of the function. But if the function is single variable function, then its derivative is denoted by small d. Okay, so if you consider f as a function of u and v, then its derivative is denoted by dA notation dA. But if we consider f as a function of t, then its derivative is denoted by small d notation. Or if we if I have to write the derivative of u or v with respect to t, u and v are the single variable function of t, and so its derivative is denoted by d notation. Okay, so df by dt. If you have to find the df by dt, that f is not directly function of t. F is function of u and v are the function of t, and that's why f is the composite function of t. Okay, and so its derivative with respect to t, df by dt, is equal to dA by du du by dt. Why du by dt? Or notation d, because u is a single variable function of t, plus dA by v dv by dt. Okay, so this is the first chain rule. If f is the function of u and v are the two variable function of x and y, then f becomes a composite function of x and y. Now f is the function, if you consider f as a function of u and v, then it is a two variable function. And if we consider u and v as a function of x and y, then are also two variable functions. Now all are the multivariable functions, and therefore notation is dA. So dA by x is what? F is composite function of x and y, and so dA by x is dA by du by x, and dA by v, next term, plus dA by v by x. Okay, so f is a function of u and v and u and v are the function of x and y. Then this f is a composite function of x and y, and then dA by x is what? DA by u by x, and f by v by x. This is the partial derivative with respect to x, and the partial derivative of f with respect to y is what? DA by y is what? dA by u by y, dA by v by y. And this is our second theorem, second chain rule. Okay, so the proof of the chain rule, here is the statement of the chain rule, that if u is the function of x and y, is a differentiable function of x and y, and x is equal to phi t, y is equal to psi t, means x and y are the function of t, like this. And then as a differentiable function of t, then prove that the composite function u, now u is the function of, now composite function of t, u is equal to phi t, psi t, u is what? F of x y. So f of phi t psi t, right here f is differentiable function of t, and obtain the formula for its derivative. That is where to find the partial derivative of u with respect to t. That is, this is why to prove. U is the function of x and y, and x and y are the function of t, and therefore u is the composite function of t, and therefore its derivative du by dt. Why notation d? Because u is a single variable function. If we consider u as a function of t, then du by dt is what? Dava u by dava x. So now if you consider u as a function of x and y, then it is two variable function, and so derivative of u with respect to x and y is denoted by notation dava u by dava x dx by dt. Now x is the function of single variable t, plus dava u by dava y dy by dt. Okay, so this is the chain rule, and now we have to show this. Okay, so the proof of this chain rule, we'll see the proof of the chain rule. So u is the function of f of xy, means u is the function of x and y as a differentiable function of x and y. X is phi t, y is equal to psi t, are also the function single variable functions of t. Then the composite function u is equal to f of phi t psi t is differentiable function of single variable t, and its total derivative is this du by dt is what? Dava u by dava x dx by dt plus dava u by dava y dy by dt. We have to prove this. Okay, u is the function of x and x and y are the function of t. Now the proof of this theorem, we have given that u is equal to f of xy, u is equal to f of xy, x is phi t, y is equal to psi t. Let delta x is equal to, this delta x is what? Phi t plus delta t minus phi t. What is delta x? Phi t plus delta t minus phi t. And suppose delta y is psi t plus delta t minus psi t. We increment in x and y respectively, corresponding to increment delta t in t. Okay, so these are the delta x and delta y are the increment in t, in x and y, corresponding to increment delta t in t. That is, if we increase t by delta t, then x is increased by this, that is delta x, and y is increased by delta y. Okay, because x and y are the function of t, and if we change or if we increase t, then delta x and delta y also increase or change. So if we change t by delta t, then the change in x and y are delta x and delta y. These are the delta x, that is phi t plus delta t minus phi t, and the change in y is delta y is equal to psi t plus delta t minus psi t. As a u is equal to f of xy is differentiable by increment theorem. What do we have? This is the increment theorem, or this is the definition of the differentiability. So delta u is dava u by dava x delta x, dava u by dava y delta y, plus epsilon 1 delta x plus epsilon 2 delta y. So u is the differentiable function of x and y. So what is the definition of differentiable function? The differentiable function is the function fxy is called differentiable function of x, differentiable function if what? Delta f means what? Delta f means delta u. Now f and u are both are same. Delta u is equal to what? H. What is the h? Notation for h is delta x, and notation for k is delta y. So h, then capital A or fxab. Fxab means what? The derivative of f with respect to x, means dava u by dava x. Here the notation for f is u. So dava u by dava x, h fxab, that is dava u by dava x, plus k fy. Fy means what? The derivative of f or u with respect to y, plus h phi hk. H means delta x, phi hk is epsilon 1, here is denoted by epsilon 1, phi and psi. This epsilon 2 means psi. K, k psi x hk, okay? So epsilon 2, okay? And where epsilon, where phi and psi tends to 0 as hk tends to 0, 0, okay? So here is phi and psi denoted by epsilon 1 and epsilon 2. So epsilon 1 tends to 0, epsilon 2 tends to 0 as hk. H means delta x, k means delta y tends to 0, 0. So u is equal to fxy is differentiable function by increment theorem or by definition of differentiable function. What we have? We have delta u is equal to dava u by dava x. Actually delta u, this is the definition of the differentiable function. Df, delta f or u both are same. Delta u, delta u means f of x plus delta x, y plus delta y minus f of x y, okay? So uh, f of h plus x plus h, y plus k minus f of x y. So it is here h and k are delta x and delta y. So in a previous topic of differentiability, we can also use the notation for h and k as delta x and delta y. So uh, we can modify the definition as well as all theorems by using h as delta x and k as delta y in the previous topic differentiability, okay? Already the notes in the form of h and k, and if, in the place of h and k, delta x and delta y, these two types notes are shared with you already through WhatsApp. So either use h and k notation or delta x and delta y. Here is the notation for h and k or delta x and delta y. So as a u is of differentiable function, and therefore delta f or delta u expressed in this form. What? H fx ab. H means delta x, fx means the partial derivative with respect to x of f. Here is f notation for f is u. So dava u by dava x plus delta y means k, dava u by dava y, fy. Then h into phi, notation for phi hk is epsilon 1. And the notation for psi is here epsilon 2, k pi psi hk, okay? So where epsilon 1 and epsilon 2, that is phi and psi, tends to 0 as hk tends to 0, 0, that is delta x delta y tends to 0, 0. So this is actually the definition of differentiable function. So write first this definition, and the u is equal to fxy is differentiable function of x and y. This is given that this u is equal to f of x y is differentiable function, and therefore we have this. Suppose this is equation number 1. Then delta u is equal to, take delta x common from these two terms and delta y common from these two terms, and dividing throughout by delta t. So we have delta x by delta t, delta y by delta t. This is equation number 2. As x is equal to phi t and y is equal to psi t are differentiable function of t, we are given also this x and y are the differentiable function of t, and therefore they are continuous, because every differentiable function is continuous, and therefore these are the continuous function of t, and hence delta x and delta y tends to 0 as delta t tends to 0. That is, if delta t tends to 0, then delta x and delta y also tends to 0, and therefore epsilon 1 and epsilon 2 tends to 0 as delta t tends to 0. Actually, when the epsilon 1 and epsilon 2 tends to 0, if delta x delta y tends to 0, 0. But if delta t tends to 0, then delta x delta y also tends to 0, and therefore epsilon 1 and epsilon 2 tends to 0 as delta x tends to delta t tends to 0. If delta t tends to 0, then delta x delta y also tends to 0, 0, and then epsilon 1 and epsilon 2 tends to 0. So combined statement is what? Epsilon 1 and epsilon 2 tends to 0 as delta t tends to 0. Then taking limit as delta t tends to 0 of equation 2. Previous that delta x by delta t as delta t tends to 0 is dx by dt. This is the definition of derivative, Leibniz definition of derivative, that limit delta t tends to 0, delta x by delta t is dx by dt. The change in x divided by change in t as delta t tends to 0 is dx by dt, and delta t tends to 0, delta y by delta t is dy by dt. So this is by using the definition of Leibniz definition of derivative. So we have this, d delta x by delta t as delta t tends to 0 is dx by dt, When delta t tends to 0, delta y by delta t is dy by dt. And then taking limit as delta t tends to 0 of equation number 2 of both sides. So what we have, limit delta t tends to 0, delta u by delta t is equal to limit delta t tends to 0 of this bracket, limit delta t of t tends to 0 of this quantity, then limit delta t tends to 0 of this quantity, limit delta t tends to 0 of this quantity. Okay, because limit of addition is addition of their limit, limit of multiplication is multiplication of their limit, limit of this total whole factor RHS is what, limit of this plus limit of this, and limit of this is what, limit of this into limit of this plus limit of this factor into limit of this factor. So addition, limit of addition is addition of their limit, and limit of multiplication is multiplication of their limits. And therefore we have, by using the definition of derivative, this is du by dt, and this is what, limit delta t tends to 0, dou u by dou x. This is constant, this dou u by dou x is constant with respect to limit. So no effect on that, this dou u by dou x. Dou u by dou x remains as it is because it is constant with respect to limit. And limit of epsilon 1 is 0 as delta t tends to 0. There epsilon 1 tends to 0 if delta t tends to 0. So limit of delta t epsilon 1 as delta t tends to 0 is 0. So we have the answer of this limit is dou u by dou x, and limit delta t tends to 0, delta x by delta t is dx by dt. So we have this term. Okay, plus similarly dou u by dou y, its limit is itself dou u by dou y, and limit of epsilon 2 is 0. So here the limit of this bracket is what, dou u by dou y into limit delta t tends to 0, delta y by delta t is dy by dt, by using the definition of this derivative. And this is the first chain rule, which proves the chain rule number 1. Okay, which proves this. Okay, the second form of the chain rule, if w is equal to f of uv is differentiable function of u and v, that is w is the differentiable function of u and v, and u and v are the function of x and y, differentiable function of x and y, then the composite function w is equal to f of phi xy psi xy, that is the composite function, is also differentiable, and dou w by dou x is dou w by dou u by dou x plus dou w by dou v by dou x, and dou w by dou y is what, because w is the composite function of what, x and y, then w by dou y is what, dou w by dou u by dou y, dou w by dou v by dou y. So w is the function of u and v are the function of x and y. And so we have this. So the proof of this chain rule. So since u, v, w all are the differentiable functions, we have, by using the definition of differentiable function, delta u is equal to, delta u is what, the increment in u is phi x plus delta x, y plus delta y minus phi xy is equal to dou u by dou x delta x, dou u by dou y delta y, epsilon 1 delta x plus epsilon 2 delta y, because u is the differentiable function of x and y, and therefore we have this by using the definition of differentiable function. So actually what is the definition of differentiable function? That delta u or delta f is equal to h. What is the notation for h? Is delta x, h fx ab. So fx means what? F suffix x means the partial derivative with respect to x, that is dou u by dou x. K dou u by dou y, that is the next notation is what, for k is delta y, and fy ab, fy means what, the derivative of that function with respect to y is dou u by dou y. Now here the function is u, and then plus h phi hk plus k psi hk. So notation for h and k are delta x and delta y, and phi and psi here denoted by epsilon 1 and epsilon 2. Obviously the limit of epsilon 1 and epsilon 2 as delta x delta y tends to 0 0 is 0. Okay, so the combined statement is after these three definitions, then delta v is what, delta is v is what, is the function of x and y, psi x plus delta x, y plus delta y minus psi xy is what, del by v by del by x delta x. Again, the same definition of differentiability. H fx ab. Here is the notation for f is v, because v is now differentiable function. So delta x del by v by del x, delta y del by v by del y, epsilon 3 delta x, epsilon 4 delta y. Again, the same definition. And then w is the differentiable function of u and v. And so f of u, w is what? F of uv. So f of u plus delta v, v plus delta v minus f of uv is equal to del by u by delta u by u w by w, because here w is the function of x and y. So h is delta u now, w by u plus delta, right here delta v, here delta v w by v plus epsilon 5 delta u, epsilon 6 delta v. Now h and k are delta u and delta v, and w is the function of u and v. So that's why w by w and w by w. So these u, v, w are all are differentiable functions, and therefore by using definition of differentiable function, we have this. Okay, equation number 1, 2, 3, where epsilon 1, epsilon 2, epsilon 3, epsilon 4, all these are tends to 0 as delta x delta y tends to 0 0, and this epsilon 5 and epsilon 6 tends to 0 as delta u delta v tends to 0 0, by using the definition of differentiability. Then using equation 1 and 2 in 3. So first write the equation number 3. What is the equation number 3? This is the delta w. Delta w is w by w by u, w by v, epsilon 5 delta u, epsilon 6 delta v. So take first this delta u common factor from first term and third term, and delta v from second term and last term. So we have this, and then substitute the values of delta u as this, delta u as this, and delta v as this. So we have this, this bracket, value of delta u is this, plus this bracket, value of delta v is this, from equation number 1 and 2. From equation 1 and 2, using in 3, we get this. Okay, and then multiplication of these two brackets. So this bracket contains 2 terms, this bracket contains 4 terms, and therefore their multiplication contains how many terms? 2 into 4, 8 terms. And also the multiplication of these two brackets, this bracket contains 2 terms, this bracket contains 4 terms, and therefore their multiplication contains 8 terms. What are that? This into this, first term, this into this. So write that term, w by u, u by x delta x. Okay, then next term is what? This into this, then this into this, this into this. In this way we have the total 8 terms, then epsilon 5 into this, epsilon 5 into this. Okay, and here we have also 8 terms. Out of that, the first 2 terms are collected in this bracket. So what are that? w by w, w by w by x delta x, and this w by v by x delta x. So from these 2 terms, take delta x common factor. So w by w by x, and w by v by x in bracket into delta x. And from these 2 terms, that is what? w by w by y delta y, and w by v by y delta y. Take delta y as common. So what do we have in bracket? w by w by y, w by v by y, and then delta y. And these are the total. Now 4 terms are covered here. So the remaining 12 terms, what are the remaining 12 terms? Total we have here 8 terms, that is we have 16 terms. So out of that, these are the 4 terms, and remaining 12 terms. What are the remaining 12 terms? This into this, that is contains epsilon 1. Then this into this contains epsilon 2. This into this contains epsilon 5. This into this contains epsilon 5. This into this contains epsilon 1 and epsilon 5. So the remaining terms contains one of the epsilon 1 to epsilon 6. At least one of the epsilon 1 to epsilon 6. So alpha 1, all the remaining 12 terms are denoted by these notations, these terms, alpha 1 delta x plus alpha 1 delta x plus alpha 2 delta y. So what is alpha 1 and alpha 2? What are the remaining 12 terms? So if we observe the remaining 12 terms, then their coefficients are either delta x or delta y. Out of the 12 terms, 6 terms contains coefficient delta x, and 6 term contains the coefficient delta y. So take that delta x as common, delta y as common. So epsilon 1 is the addition of 6 terms, epsilon 2 is the addition of 6 terms. So here is the epsilon 1 and epsilon 2 are sum of terms, each containing the factors epsilon 1, epsilon 2 to epsilon 6. So this epsilon 1 and epsilon 2 are what? Is the sum, epsilon 1 is the sum of 6 terms. Epsilon 2 is the sum of 6 terms. And all these terms contains the factors, one of the factor epsilon 1 to epsilon 6. And hence, epsilon 1 and epsilon 2 tends to 0 as delta x, delta y tends to 0, because this epsilon 1, epsilon 2 to epsilon 6 tends to 0 as delta x, delta y tends to 0. And therefore, the limit of alpha 1 and alpha 2 is 0 if you take delta x, delta y tends to 0. Then putting delta y is equal to 0 in equation number 4. This is the equation number 4. What is the equation number 4? This is the equation number 4. Its LHS is delta w. So putting delta y is 0 and dividing by delta x. What we have? Delta w by delta x is the LHS. And then here is this bracket, delta x by delta x is 1. Okay, we have this bracket plus this bracket, delta y by, actually the value of delta y is 0. So this term becomes 0. And then here is plus alpha 1. So if we substitute delta y is 0, we have this term is 0, this term is 0. And if we divide by delta x, then we have delta w by delta x is equal to this bracket, this bracket, this bracket, delta x by delta x is 1, delta x by delta x is 1, and this is plus alpha 1. So this bracket plus alpha 1, if we substitute delta y is equal to 0. And then taking limit as delta x tends to 0 of these both sides, we have delta x tends to 0, delta w by delta x is dabba w by dabba x, and limit of this factor is itself, and limit of alpha 1 as delta x tends to 0 is 0, because alpha 1 and alpha 2 tends to 0 and delta x and delta y tends to 0. Actually delta y is 0 and delta x also tends to 0, then limit of alpha 1 is 0. So we have dabba w by dabba x is this, dabba w by dabba u by dabba x, dabba w by dabba v by dabba x. Similarly, if we substitute delta x is 0 in equation number 4, and if we dividing by delta y, and if we take the limit of both sides as delta y tends to 0, then we have this dabba w by dabba y, dabba w by dabba u by dabba y, that is this term, and dabba w by dabba v by dabba y. So no need to prove this or write the same procedure, that putting delta x is equal to 0 in equation number 4 and dividing by delta y, and then take limit as delta y tends to 0, we have this. Okay, so this is the second format of the chain rule. Now we will see the examples on this chain rule in the next lecture.